In topic 3, we're going to discuss subtracting rational expressions with common denominators. We've already looked at fractions, and remember, with fractions, as long as you have a common denominator, you add, or in this case, subtract your numerators, you put it over the common denominator, and then you simplify at the end. Same exact thing is going to be true with rational expressions. So you can see here, we say if P over R and Q over R are rational expressions, then P over R minus Q over R is going to equal P minus Q over R. You just keep that common denominator and subtract your numerators. We do have one condition. We have to remember that R has to be anything but 0, okay? You cannot have zeros in your denominators with fractions or rational expressions. Now, as far as rational expressions are going to go, when we're subtracting with common denominators, we subtract the numerators, and this thing that I have in parentheses, make sure you understand it. So make sure to distribute the negative through the second numerator. So I talked about this when I showed you adding rational expressions. I made a point of putting my numerators in parentheses and then showing that we had to distribute a 1 to like technically officially get rid of the parentheses. I showed you there just so it wouldn't be quite so shocking here. You have to do that here, especially for that second numerator, okay? You have to subtract the entire second numerator, which means distribute a negative through that second numerator and then combine like terms. So once you find your difference, you put it over the common denominator and then you factor at the end and simplify, okay? So let's go ahead and take a peek at this. So example 3 says find each difference, okay? Remember, difference just means subtract. So we have 3x squared over x squared minus x minus 2 minus 6x over x squared minus x minus 2. Notice we do have common denominators, so we can proceed. We need to, it's not going to be as big a deal here, but you do need to note that it's like this numerator over this numerator. And again, it's not going to be a big deal here. In the second example, making sure your numerators are very distinct is a big deal. So in this case, we can just subtract our numerators. We get 3x squared minus 6x. You don't really have to do any distributing here. There's just that single term in both numerators. The denominator is x squared minus x minus 2. So we've subtracted the numerators, we've put it over the common denominator. Now at the end is when we want to factor and simplify. So looking at my numerator, I definitely have a GCF, 3x squared and 6x have a 3x in common. So I want to write 3x times whatever my quotient is after I divide out the GCF. So 3x squared divided by 3x. Well, 3 divided by 3 is 1. X squared divided by x is x. So that just becomes 1x. And then negative 6x divided by 3x. Well, negative 6 divided by 3 is negative 2. And then x divided by itself is just 1. So we just get 3x times x minus 2. Okay? Now my denominator is a quadratic trinomial, and luckily it's a quadratic trinomial where the coefficient on the square term is 1. We can do that easy shortcut factoring. So we know this is going to factor as two binomials, each starting with an x. And then what we need to do is look at c, the constant. So we need to find factors of the constant c, which is negative 2, that have a sum of the coefficient of x, which is negative 1. So when we're dealing with factors of a negative number, those factors have to have different signs. One has to be positive, one has to be negative. So we could look at negative 2 and 1 or 2 and negative 1. Well, in order to get a negative sum when you're looking, negative sum, when you're looking at two factors with different signs, the larger of the two factors needs to be the negative. So you can kind of see that here. Negative 2 plus 1 is negative 1. 2 plus negative 1 is 1. So that's our magic pair of factors that's going to work. So we want to go x minus 2 and then x plus 1. And at this point, you want to look to see, do I have any factors that cancel? And in this case, yes, you do. You have an x minus 2 in the top and an x minus 2 factor in the bottom. So x minus 2 divided by itself is just 1. So that leaves me with a numerator of 3x times 1, which is just 3x, and a denominator of x plus 1. So that's your final answer, okay? Now, part B, we have to be much, much more careful with, okay? In part B, I need you to understand that this is one polynomial and this is another polynomial, and we have to eliminate parentheses by distributing ones, okay? That is absolutely pivotal. So we already talked about adding and subtracting polynomials a couple of chapters ago. And when we did that, when we were talking very specifically about subtracting polynomials, we had to remember to subtract that negative through the second polynomial. We have to do the same thing here, okay? So luckily we have a common denominator. It's x squared minus 3x minus 28. So we can go ahead and set that up as the denominator. And then for the numerator, let's get rid of our parentheses. So for the first polynomial, we're just distributing a 1. So 1 times 3x squared, 1 times 8x, 1 times negative 1. It's the second polynomial that you have to be careful with because you're distributing a negative. So it's negative 1 times 2x, negative 1 times 2x squared, negative 1 times 2x, and negative 1 times negative 9. So make sure you watch your signs. You should have positive 3x squared, positive 8x, negative 1, negative 2x squared, negative 2x, and then positive 9. And now we want to combine those like terms, okay? So let's see here. We definitely have x squared terms. We have x terms. And we have, let me change colors. We also have constant terms. So when we go to simplify the numerator, you've got 3 different types of terms that need to be combined. Let's start with the squared terms. So 3x squared minus 2x squared is just going to be x squared. 8x minus 2x is going to be 6x. And then negative 1 plus 9 is going to be positive 8 or plus 8. And then that's still over that same common denominator of x squared minus 3x minus 28. So we have to do 2 factorings. We've got a numerator and a denominator. Both are quadratic trinomials where the coefficient of the square term is 1. So let's look at the numerator. So for the numerator, we need to find factors of 8 that have a sum of 6. Okay, so we need factors of 8. That means both factors have to be positive or both factors have to be negative. And in order to get a sum of positive 6, that tells me the factors need to be positive. So we could look at 8 and 1 or 4 and 2. And the pair that's going to work for us will be 4 and 2. 4 times 2 is 8. 4 plus 2 is 6. So my numerator is going to factor as x plus 4 over x plus 2. Okay? Now for the denominator, we need to, again, we have a quadratic trinomial where a is 1, so we just need to find factors of c that add to b. So we need factors of, what was it, negative 28 that have a sum of negative 3. So in order to find factors of negative 28, one has to be positive, one has to be negative. And if their sum needs to be negative, that tells me the larger of the 2 factors should be the negative factor. So let's see, we could have negative 28 and 1, negative 14 and 2, negative 7 and 4. And of those 3 pairs of factors, negative 7 and 4 is the pair that adds correctly. Negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. So my denominator is going to factor as x minus 7 times x plus 4. And now we want to see, does anything cancel top to bottom? And yes, we have a common factor in the numerator and a common factor in the denominator of x plus 4. So let's see what that looks like. Well, x plus 4 divided by x plus 4 is just 1. And so that's going to leave me with 1 times x plus 2 in the numerator and 1 times x minus 7 in the denominator, and that would be our final answer. So just use a lot of caution with adding and subtracting. Typically, when students work with fractions, they think adding and subtracting is much more complicated than multiplying and dividing. And I would say that's typically true if you have different denominators, which that's a different worksheet. So just make sure you practice both multiplying and dividing and adding and subtracting. And part of what you're learning is what steps go with which operation. So multiplying and dividing, make sure everything's multiplied or written as multiplication. Factor first, simplify, then multiply. With addition and subtraction, you add or subtract first, then you factor and simplify. So just be really careful, especially with subtraction. Make sure you subtract that entire numerator, okay? So practice, practice, practice. In the next video, we're going to look at those weird opposite factors, okay?